Hope you're all doing extremely well. In this video, we are starting about the neural style transfer. So our concept is mainly the application of the deep learning. So nowadays you can see a deep learning and the artificial intelligence has a great advantages and applications in every domain, each and every domain, and they have a very good application and it is a booming technology. So one such technology that we are discussing is a neural style transfer. So what exactly does the neural style transfer do? So before this, I just wanted to glance. Have you ever wondered a normal clicked image can be converted as a painted image by a great artist, right? So that can be achieved by the neural style transfer. Okay, so neural style transfer basically take a some image, any image that you have clicked, and it converts into kind of painted shape or the painted image. So this is a very good advantage of the neural style transfer and a deep learning. So we use such kind of technology in a very major industries which are very much concerned with the mobile applications and who are very much concerned with the applications like the image filters and all. Okay, so let us go and understand how we can achieve such technology using all the deep learning techniques. So let us start with our session. So now first let us understand what is a content image, what is the reference image, and how we can combine those image to achieve the combined image. Okay, so here I am talking about the content target. So I have a target image here. You can see a target image is a normal image. Okay, and I have some style as a reference. So I'm using this style as a reference. The combination of the content as well as the style will give you the combined image. So this is a targeted image. So basically the target as well as the reference image will give you a generated image. So this is generated by using all these two images. So now you can observe that this is the target image, and from the second image only this style of this second image is copied without changing the content in the first image. That is very important. If you could observe, only the style of the second image or the reference image is being copied. So this can be achieved using the neural style transfer. According to the definition, neural style transfer consists in applying the style of a reference image to the target image while conserving the content of the target image. So this is a major advantage of a neural style transfer. Style, what is the meaning of style? Let us understand what is style. Style is essentially a texture. You can take colors or the visual patterns. Here you can see the spiral patterns which is there in this reference. This is all called as a style. Okay, that can be copied or that can be incorporated in this particular image. Content is referred as these houses or the particular whatever the content we have, maybe this tree and this lake, anything. So this style from the second image or the reference image is copied on the target image and which consists of content. So content is preserved when you generate such image. So such technology is called as the neural style transferring. You're just transferring the style, nothing more than that. Okay, so let us understand how we can achieve this and what are the technologies that we are going to use. So now notion behind the implementing the style transfer. So what are the main base of the style transfer and what is the loss function and how to derive those loss function using the mathematical terms. So here the notion behind the style transfer is that we all know that image, so whatever the image that we are going to generate is nothing but the combination of content plus style. Okay, so we actually know this concept. So what is the content? We should retain the content. We should retain the content and style should be adopted to the given content, right? So this style should be adopted to this given content and together the combination will give you new generated image which looks like a painting. So as usual, if you take any model, maybe in the machine learning, deep learning, we actually derive the loss function. What exactly is the loss function? So we all know that here the loss function is nothing but the function which will give you a difference between the original image and whatever you are generated. That difference, that loss should be less. So basically here, if you observe, for the loss we have two particular portions. So this is what the part 1, this part 1 or the content contributes to the loss, as well as you have the second loss that is called as the style loss, right? So what do you mean by content loss? So basically you have the original content and generated content. So this original content and the generated content image should be having a same similarity. That means the loss between these two should be very much less. Okay, so this is about the content loss. Then if I talk about the style loss, it is similar. So whatever is in the reference image, okay, and if you take the difference between the reference image and the generated image, the loss between these two should be always less. So basically the content loss as well as the style loss totally will give you the loss for the image in the generated image. I hope this is clear for you all. So now let us understand how mathematically we can see that. So loss is nothing but the distance. So distance here is the L2 norm. So this distance acts as the hyperparameter for the optimization later. So by increasing the distance or by decreasing the distance of either content or the style, we can perform this particular image optimization. Okay, so style is the reference image. So that is the difference between the first one, that is the reference image, and the style of the generated image, plus, as I mentioned, the content of the original image and the negative, that means the difference of the content of the generate image. So I hope this is clear for you. Basically you have a style and also you have a content. Okay, so I hope this is clear for you. This mathematical portion is very important in order to perform a very good style transfer images. Okay, because if the loss is more, you won't get that accurate and the perfect images properly. So now let us understand what is the content loss and what exactly is the style loss, how we can compute it and how we can derive those losses here. So the content loss is a function that ensures the activation of the higher layers and are similar between the content image and the generated image. As we all know that higher images, that is the higher layer in the neural network. So basically I'm using the convolution neural network, will possess the more information. So what exactly is the content loss, then how you can compute that? So let's say this is the generated image. So I have generated the image. So the content loss is between the last layer or the higher layer. Here it is just the third layer, and between whatever the generated image. Okay, so this basically says only the loss between the higher layers, the content loss will be computed. If you take the style loss, it is of not that type, because style loss function makes sure that the correlation of activation in all the layers are similar, because you are following the style. Okay, so you should have a correlation of activation in all the layers of whatever the generated image is generated and whatever the reference image that you have taken. So style loss can be calculated with respect to all the layers of the neural network, when the content loss is calculated only in the higher layers of the neural network. So totally content loss and style loss will give you the total loss in your generated image. I hope this particular definition is clear for you all. Now let us go and understand how we can mathematically compute this. So before going to that, as I already mentioned, that style loss is nothing but it consists of all the layers. So for this all the layers, it is kind of bit complex to understand. So that's why we have something called the gram matrix. So what does the gram matrix will do and how this is helpful, let us understand. So we don't use the gram matrix in the content loss, we only use it in the style loss because style loss consider all other layers with the generated image with respect to the reference image. So if you take the style loss uses the multiple layers, we try to capture the appearance of the style, very important, from the reference image to all the spatial scales extracted by the convolution neural network, not just in the single scale. You have to just see the style of at all the scale, all the spatial scale, not in just only one layer or not in just only one scale. Okay. So for the style loss, we use the gram matrix to achieve this particularly, to understand and to extract all the information, all the style, we uses the gram matrix. It uses the inner product of the feature maps of a given layer. So basically gram matrix is such kind of matrix which performs the inner dot product. So here, let's say I have two features. So let's say feature A and I have a feature B. Okay, so these are the pixels. We can say these two features will be taken as a dot product in the gram matrix, and it will just see, okay, if the two features are similar, what it will do, and two features are not similar, that can be given by the dot product and using the gram matrix. So gram matrix is computed over the flattened feature, that is what these features. So flatten in the sense you will be having the features which is in the row matrix, because row matrix is higher dimensional, we have to convert back into the column matrix. So very close, then its value is so larger. So basically flatten features vectors and says that if two features, let's say if these two features, okay, between the generated image and the reference image is so close, okay, so it's more loss. That means if they are actually close, then its value is larger, so it's more loss. That if two features are almost the same, so do not transfer the features that are close, right? Because there is no need of transferring the features that are actually close to each other, and do not transfer the content of the image. So basically it will maintain the content of the image and also it will just maintain the style of the image as it is. Gram matrix guarantees that the texture found at the different spatial scales look similar across the style reference and the generated image. So only because of the gram matrix, which works on all the directional spatial scales which is extracted from the reference image, so it will make sure that whatever the style in the reference image would work on the generated image by using this mathematical term, that is a dot product between all the features. So before performing the dot product, you will just flatten those features into the column vectors and you will perform the dot product. Okay. So now let us understand mathematical formula about all these things. Okay. So mathematically the total loss you can observe between the generated image and the reference image or the reference content or the target content is nothing but, as I already mentioned, it is the sum of content image. So and alpha acts as the weights, and based on the weights you can easily observe here. So here alpha acts as a weight. Let us understand what is weight. So this is the content and this is the style, and beta. So this alpha beta acts as the weight. What is the meaning of the weight? So basically here the theory is just simple. If you want to retain the content, you should give alpha that should be more. This is very, very important. The alpha that is given here should be more, and you want the style to have lesser than the alpha. Why? Because if you do this more, your content will be retained, okay, and if you say the style is less, so basically what will happen, the generated image will retain the content and it will adopt the style by using such. So you can easily tune this alpha and beta for the different weights. You are actually there is a difference in the generated image, so you can just keep the optimized alpha and beta using some of the optimization techniques. Let us discuss that in our later classes, that means the later videos. So here you can see that the content, so basically the total loss is what? Content loss and the style loss. So content loss is defined by like this. So it is the square of, it is the sum of the square of the loss between the original image and the generated image. So this is the original image and this is the generated image. As I already mentioned, loss is the content loss and the style loss. So this is about the mathematical representation of the content loss. Now we are left with what is the mathematical representation of the style loss. Here you can observe that. So mathematically, style loss is represented by this. That is also a square of whatever the reference content is there and whatever the new generated image is there. So, but since, as I already told you, it will perform on all the layers of the neural network, it takes a support of the gram matrix. So gram matrix is nothing but inner product between the vectorized features maps, that is ij, in the layer L. I mean, for the particular layer, it will take all the features from both the layers and it will perform a particular dot product between the two layers. If those are similar, then it will retain it, it will not do any changes. Okay, so exactly like this you can compute the gram matrix and the style loss. Now we are familiar with how the style loss and the gram matrix looks and mathematically how you can represent. Now let us go and understand what are the networks that we will use here in order to achieve such technology. Okay, so basically deep learning will have the neural network structures. We already know that it will be having many hidden layers and many layers. So one such very amazing deep learning technology, we call it as the convolution neural network. Using the CNN, we can achieve this style transfer. So under the CNN, I'm basically using the VGG16 network. This is a special network that we are using for the neural style transfer. Okay, so it can be implemented by using the pre-trained convolution neural network. This is the pre-trained network. Here we will use the VGG19 network. Okay, so now in our general process, what are the general process that we will use using all these neural networks, that is convolution neural network? Set up a network that will complete VGG layer activations for all the style reference image on the target image and generated image at the same time. That means to say that you have to set up an image to give, you have to provide that network basically reference image, content image, and you have to provide the space holder for the output, which is the generated image. Okay, so use the layer activations. I mean, here you can use some of the layer activations, and also loss function can be described because you need to have the loss function in order to see the performance of the network. More the loss, less is the performance. More the loss, less is the best image that we are going to obtain. Okay, set up a gradient descent process. Obviously here also optimization follows a gradient descent process. So what is the gradient descent? In the smaller step, you have to get a very well hyperparameters. Okay, so you have to achieve a good hyperparameter in the smaller steps. That means it is optimization technique. Okay, so we will understand all these things by using the coding technique. So I have a very good coding platform. I am using the Colab for this particular coding because Colab will provide you a great platform in order to have a very good neural network. Since the neural networks take so much of memories, it might take some time. Okay, so Colab is a very good platform, I feel. So let us go and understand how we can code and how we can achieve whatever the problem statement or the style transfer using the Colab. Okay, so see you there in the notebook session. Now let us have a walkthrough through the code for the particular problem statement of a style transfer, right? So basically I'm starting with importing all the essential libraries. So firstly, I'm downgrading the SciPy and I'm downloading a SciPy of version 1.2.0. So what does that mean? As usual, nowadays we have a SciPy of version 1.6.3. I have to downgrade it to 1.2.0. The reason is because this particular version of the SciPy will not give enough advantages or enough performance to the style transfer. That's why I need to adopt the downgrading SciPy library or the SciPy version, that is 1.2.0. So I'm installing pip install the SciPy. So next I'm importing the TensorFlow of the version 1.x, and I'm also importing the Keras of the version 2.3.1, in which the TensorFlow as the backend. So I have installed the SciPy and imported the TensorFlow and the Keras. All these three libraries are the major and very advanced libraries in the deep learning or any deep neural networks. Okay. So now let us understand how we can start with the pre-processing and the coding portion. So this is what our problem statement, like as I already mentioned, style transfer is the content image and you have to retain the content in this image, and you have to just take the reference style and you have to adopt the style to the image you retaining the content, and you have to get the combination of image like this. So, and also we discussed about what is the loss. Loss is nothing but the summation of content loss as well as the style loss. Also we discussed and derived mathematically that start with the pre-processing of the data. We already know that whatever the data we are going to build a model, we need to pre-process the particular data. So what exactly pre-processing the image means? We all know that image pertains some pixels. Okay, so whatever the image that we have, we need to convert that image into vector form. So that is what actually we are doing here. So we have the images. So here you can observe that we have the target image. I am giving the target image here. So basically my target image is this. So now you can see this is the image of the rabbit. I have this as the target image. So this is the image in which I want a content of the particular image. Okay. So also I have next image which is called as the style image. So what is my style image? I have a style image here. You can observe that this is the style image. So basically I want to merge this style with that content. That means I want to somehow implement this style in the particular content image without changing the content of the image. So this is very, very important. Now let us understand what are the code we need to follow, and we will walk through all the coding here. Okay, so now you can see that I am giving the image, and also I am giving the image like load the image and all those things. I am making the width of both the image as the uniform. So I am making it as the 400 pixel. So basically I am just making two images which is there. So that is the content image and the target image into the same dimensions. Okay, that is I am giving it as the height as 400 pixels. So next you can see I'm loading those images here. So using the VGG19 network. So next I'll be feeding those images. Whatever I have pre-processed, I just converted those images into pixels, that is indirectly a vector. I need to feed it to the VGG19 network. So here I'm starting with the data pre-processing. So in this I'm just mentioning that target image and this is, so do some processing and return the image. That means I'm giving that particular image to VGG19 network. Then after that I need to just give all these three images. So basically we have the three images. I need to give a place for all these three images. So you can see, let us set up the VGG network. I am setting up the network in which a batch of three images is sent. So what all those images? One is the image which is content, one is the image which is the style. Next you can ask me what is the third image? Third image is nothing but the placeholder. It is very static. It is a placeholder which is for the generated image. So I'm giving that dimension and I'm converting the BGR to RGB. Okay, that is red, green, blue scale. Okay, the style reference image, target image, and you can observe that is a placeholder for the generated image. So and here you can observe that the values provided by the NumPy arrays, these are the values which is provided by the NumPy arrays for the particular dimension. The style reference and the target image are static. As I already told you, these two are actually static because we know what is its dimension and what is the pixel. But when you compare to the other image placeholder, this is not static because it is not at all fixed yet. It is just a placeholder. So you need to introduce the constant there, so that in order to make it as fixed, because it should not be moving, it should not be dynamic. I hope this is clear for you all. I'm just giving the batches of 3 images, 2 images and one is the placeholder. 2 images are actually dynamic, whereas static, whereas the third placeholder is dynamic. You need to keep it as the constant. So next, let us walk through this code. So here what am I doing? I'm just concatenating all the 3 images. I'm just sending it to the input. Okay, I'm just making that third image as the combination of all these 2 images. So I'm just giving it to the VGG network. Okay, so I'm just making, I'm using the ImageNet. Okay, so we are using the VGG network and the batch of 3 images as the input I have given, and the model will be loaded with the, already I have a pre-trained model with me and I'm calling it as the ImageNet, and I'm giving the ImageNet all these 3 particular images. Okay. So next, very important, as I already mentioned, once you give the image, next very important thing, whatever you are looking at the observation, it should be proper. That means the loss should be very, very less. So next I have to look into what is the content loss, what is the style loss. So mathematically already we know that it is the sum of the square of, this is very important, combination and the base. Combination means a combined generated image. Base means, it means that whatever the content image that you had. So basically content loss is the loss between the content and the generated image. So next, very important, I have to look for the style loss, because loss is a combination of content and the style, as I mentioned. Now I am looking for the style loss. So for the style loss, as I already mentioned, it operates on all the layers. So you have to take the gram matrix. So here I am taking the gram matrix. Basically, gram matrix is a dot product of the inner particular maps or the features. So I'm just taking the gram matrix. I'm flattening the particular feature by transposing. Transposing will give you a column vectors. Okay, so this is about the gram matrix. Next, after that I have to look for the style loss, because I have achieved the gram matrix. You can use this gram matrix in order to find what is the style loss. Okay, somehow now we are familiar with the content loss, and we can also see what is the style loss here. So after that I have to see the total variation loss. That means, what is this total variation loss, because we didn't discuss in the theory portion. So basically this total variation loss will be used in order to, whatever the generated image should be very much pixelated. It should not be having the over pixels. So what does that mean? That means we have already seen that we know that the loss is nothing but a loss of content and the style loss. So what is this variation loss now? So we know that the content plus a style of an image. So totally combination will give you a image which is generated. Okay, that is what we will get, a generated image. This generated image should not have more pixels or overlying pixels. So what is the meaning of overlying pixels? As we all know that the moment the pixel is increasing, that means to say that you are increasing the size of an image. So what will happen if you increase the pixel? Obviously it is a common thing that you will get a blurred images. So in order to avoid this blurring of the image, you are using the total variation loss. That means you are just, whatever your generated image is there, you are just measuring what is the total variation loss, and you are just minimizing that, because you have to keep that loss a very, very minimum. Okay, so why? Because in order to avoid the blurring of the image. So I hope you are clear with this. What is the meaning of total variation loss? So this is what it is. Now let us understand how to start with mapping. Okay, so mapping means, now I can see I'm just giving all these input into the VGG network, that is network which will be using for the analysis. So here you can see I'm just giving for the content layer, as I already mentioned that it will use just only upper layer or the higher layer in the given convolution neural network. Whereas if you take the style layers, it will use from the beginning to the end of, it will use all the style of all the layers, because that is important. It should capture the style from the beginning to the end. Next, you can observe that I am giving some weight. Okay, so the weighted average of all these loss components. So here you can see total variation weight. I'm giving this. As I already mentioned, we need to provide some weight in order to minimize the loss. Okay, so give some weight so that your image won't be that blur. Okay, so it is according to your image dimension. And next you can see the style. I'm giving the style as 1 here. Why 1? Because style weight should be less. Okay, so I'm giving the content weight is less. So you can see compared to the content weight, style weight is more. Why? Because content should not be changed. If you give more weight to the particular content, the content will be changed. Okay, and it will be replaced. So that's why I'm just giving the content weight as less, and whereas a style weight is more, because I'm very much concentrated on the style to be incorporated on over the content. Okay, so basically I will fit all the model, then I will see what is the content loss and what is the change loss after combining all these images. Okay, so I'm giving the weight, I'm combining the images, then I'm looking for, based on the weight, I'm looking for what is the content loss and what is the style loss. Okay, so for the particular combination. Next, very important thing, I'm using the optimization technique. As I already mentioned that you can easily change the weight of these two, content and the style, in order to get a optimized and the better images. Here it acts as the hyperparameter tuning for the optimization. This weights for the content as well as the image, that is the style image acts as the parameters, which is for the optimization, by changing which you can easily get a proper output at a particular optimized manner. So I'm using the gradient descent optimization here. Along with the gradients, I'm providing a model with a very well optimizer. We call it as the LBFGS optimizer. Basically, this is an optimization algorithm which works on the optimization techniques for the weights here. As I already mentioned that here the weights for the style and the content acts as a optimized hyperparameters. That means you can just tune those parameters so that you will get a proper output. So here I am using LBFGS algorithm. So this is the algorithm which we have to import from the SciPy. That's why at the beginning I just install the SciPy here. So this basically works on the optimization, and I'm giving the steps as 5 steps of gradient ascent. So I'm making the 5 iterations. So for every iteration it will change the weight of the particular style and the content, and it will see how the combination of these two images looks. So, and like this, basically it will go through 5 such iterations through all the network and the optimization, that is the LBFGS algorithm, and it will provide us a proper output based on the iteration. Okay, so, and that means it will fix a proper weights for the particular content as well as the style. So after running this, you can see I have run all the 5 iterations here. So after that I have to visualize whatever the images that I have got, that means the combined image, that is the style transferred image. So I'm using the matplotlib library in order to visualize those things. I'm providing the particular height and the weight width for those particular images. Now you can see this how beautifully we can create a style transfer. Now you can see the style of this content image is different before. I just want to immerse this style into this content image, that is the rabbit. Now you can see somehow the same content image is retained, but the style of the content image has been changed. Now you can observe this is a style transferred image. It looks almost like a painted one. As I already mentioned, you can see this is the image, this is the style, somehow it is converging style that you have here, and I'm just mixing all those things. I'm just transferring the particular image. This is how you can use the style transfer, that is a neural style transfer, in order to transfer the image style. So before it was just a plain image, you just combine that with some style and incorporate that style in the particular content image. I hope you guys really enjoyed the video and you understood each and every concept in a better way. So if you have any doubt, any questions regarding or any suggestions regarding our videos, please do feel free and please do provide your doubts or questions in the comment section so that we can easily give you the solution. So next we will meet again, maybe with a new and innovative idea. Until then, take care. Bye bye. Stay safe.